In this example, we're going to identify the appropriate description for the rational function given here. I always look to see if the numerator can be factored, because sometimes the factors of the numerator might cancel with some of the factors in the denominator. However, that quadratic is not factorable, so I will abandon the idea that I can cancel anything. I also notice that there is a vertical asymptote through x equals 8, because if I allow x to be 8 and try to plug in 8 for x, I will have a 0 in my denominator, which will make the function undefined. I also want to remind you that I did an intro video going through the textbook, looking at some of the examples in the book, just to give you an idea of all the things that I'd be referring to as I work through these videos. So please see that video or look in the textbook if you're wondering where I'm kind of assuming that you know certain things that are in the textbook or that I've gone over in that video. So we have the vertical asymptote, which will be a imaginary vertical line through the x-axis. If here's the y-axis, and this is the x-axis, and this is 8 on the x-axis, you will have a sort of an electric fence through that value so that the function can never touch or cross. Right? So we might have something that veers off, something like that, or possibly something like this, or it can be other things, and that's what we're exploring here, is what else could be happening. So the other thing that I notice is that the degree of the top is 2 and the degree of the bottom is 1, and we know that if the numerator's degree is 1 higher than the denominator's degree, then there is an oblique asymptote, which means slanted. So we have an oblique asymptote, and when you have an oblique asymptote, it means you don't have a horizontal. You will either have one or the other. Okay, so there is an oblique asymptote. And at this point, I'm just going to read through and see if any of the facts I've discovered about this function are in the options here, because there's going to be one correct decision, and I may have or description, and I may have already discovered it. So let's see what it says here. The x-axis is its horizontal asymptote. No, I didn't find that out, because the x-axis has the equation y equals 0. For one thing, the horizontal asymptote, well, that's not going to happen because we have an oblique one. Okay, so this isn't it. The horizontal asymptote is y equals 8. No, there is no horizontal asymptote. The graph is has an oblique asymptote. Yes, we found that to be true. So this is probably the option, since there's only one correct answer here. But let's look at the others. D, there is a hole in its graph at x equals -2. No, I don't see any reason for that to happen, because the only value that needs to be restricted is 8. The vertical asymptote is x equals -2. Again, we don't need to restrict x values, except for kicking out 8. The x-axis is its horizontal. Again, there's no horizontal asymptote. The y-intercept is 0, 2, and the x-intercept. Okay, so those are two that we could check, and I'm just going to do them, even though I know I'm very confident this is the answer. I'm just going to explore these so that you at least know how to tell if they're true or not. So the y-intercept it's saying that the y-intercept is at 0, 2. So if that's true, when you plug in x equals 0, you get a result of 2. So let's check that. F of 0, is it 2? So f of 0 is 0 squared plus 2 times 0 plus 3 over 0 minus 8. So I'm just plugging 0 into my original function. And that zeroes out. And then we have f of 0 equals 3 over negative 8. Oh, that's not 2, right? So this isn't true. And then the other one, the x-intercept is at negative 8 comma 0. So that would mean that if you plug in negative 8 into the function, you would get 0. So is f of negative 8, is that equal to 0? So taking my function again, f of negative 8 would be negative 8 quantity squared plus 2 times negative 8 plus 3 over negative 8 minus 8. So that'll give me 64 minus 16 plus 3 over negative 16. So that is 48 plus 3 is 51. And it's definitely not going to be 0. So that's not true either, right? So we know that C is the correct answer there. Now, before I move on to the next example, even though we've not been asked to in this example, I'm going to show you how we can figure out what the equation of the horizontal asymptote is and how we can determine whether or not the function will cross the the oblique asymptote. So again, we know we have an oblique asymptote, but what will it be? Well, we'll need to perform the division here. The book shows it a different way than I'm going to show it. So I'm going to show it with long division. And then x goes into x squared, x times x is x squared, x times negative 8 is negative 8x. And then we change the signs, draw the line and change the sign. And we have 10x plus 3. Then we do the same process again. How many times does x go into 10x? Goes in 10 times. And then 10 times x is 10x. And 10 times negative 8 is negative 80. And draw the line and change the signs. So then we have a remainder of 83. But we ignore the remainder, and we know that our oblique asymptote, which is a slanted line, is going to be the equation y equals x plus 10. So that would be, I'll just draw a rough sketch of it. So if this is the x-axis and the y-axis, and this is, say, 10 up here. Actually, I'm going to draw 10 a little bit lower, so I have a little bit more space. Let's say that's 10. Then we would have a y-intercept at 10 and the slope 1 over 1, so that it's going uphill 1 unit for every 1 increase of x. So it ends up being a slanted line like this, and this is our asymptote. So the asymptote will be, usually we represent it as a dashed line. Right, so that is the oblique asymptote. And also remember there is a vertical asymptote at x equals positive 8. So if this is positive 8, there's also a barrier here. Okay, now the next question is, does the function ever cross its oblique asymptote? We know for sure it does not cross its vertical asymptote at 8, but it may cross the oblique. So let's find out if that's possible. When two equations intersect, it means they share a point. So to tell if the function f of x shares a point with its oblique asymptote, we set it equal to the equation of its asymptote, and then we solve for x. So I'm going to put this over 1 and do solving a proportion when you have one fraction across from another fraction with an equal sign in between. That's called a proportion, and you can solve it by doing cross multiplication. So this will become x squared plus 2x plus 3 times 1, which will be itself, and then x minus 8 times x plus 10. Alright, and then when you FOIL this out on the right, you get x squared plus 2x minus 80. So this is what I have on each side. Now, anything that is the same on each side can be canceled out. So x squared is going to zero out the x squared over here. Positive 2x and positive 2x. So we end up with a statement 3 equals negative 80, which is untrue. There's no way this will ever be true. So that means that the function does not intersect its oblique asymptote. So this function may look something like, possibly like this, maybe something like this, and this, and I'm just, making stuff up because I would have to find out more information to know what kind of behavior is occurring in between the asymptotes. But that just gives you an idea of what could happen, and I'm not going to go any further with this example, but that's how you figure out whether or not your function will cross its non-vertical asymptote.